Hey everyone, welcome to the Electric Supercar channel. This week we're putting a Tesla motor in a vintage Porsche. So this is a 1977 Porsche 911 Targa. So as you can see, this is fully stripped and it's gonna get a complete restoration. And because I've got the best customers, this one's gonna get a Tesla drive unit with 600 horsepower. So if you haven't seen any of these videos, I'll leave a link up here so you can catch the whole build series. For now, sit back and relax and enjoy this episode. So like most of our builds, we do a scan. We scan this one. You can see it's got some really good resolution. We've got a front battery box, a back battery box, but that's not what we're talking about today. We're talking about the motor. Basically what I had to do is find out the best orientation for this motor for this vehicle. So some of the things I had to take into account, this is the drive output. We want that to be exactly in line with the hubs. And right here, the suspension is kind of at full droop. So I did some research and found this is the travel distance. This is trailing arm suspension and basically using the pivot point back here. This is at full droop. Knowing the full suspension travel, this arc is the motion that the wheel hub goes through. I put the center of the drive directly at the center of the suspension. So that's kind of what this is, these two circles. Those are kind of the output shafts. We've got a line in the middle, and that is essentially the drive output. So you see it's just a little above, but again, when this is loaded, it should be right in line. So we should have really good shaft output. The next is what points on the car can we use that would be good mounting structures. So up here, this is where there were some existing mounts for like the motor and transmission right here, as well as back here. This is, I think, more for the transmission. But just for the motor, we're gonna do these middle ones and these front ones. So I designed some tubes. So essentially we're gonna go straight and then bend over the motor and connect to this cross member. We're gonna have a forward cross member here and get some laser cut parts to mount the front motor. This is the mount that we came up with for the rear. And then the last one we had to do is a little more challenging because I actually drew a circle or a cylinder around this. The customer is thinking that they may want to do coilovers. So this represents the diameter of the coilover, and as you can see, it would run into this third motor mount. So we've got a different design that uses these same bolts and mounting locations, but basically shifts it over to the right. And you'll see that later on in the video. So this is the design, and we're gonna hand this off to John for fabrication.
All right, we're working on the Porsche today. Start fabricating the subframe and the motor mounts. So I had some parts made, basically the washer that'll go in like a cup. We'll weld them up. Those will be the main mounts to the body for the subframe. I've set up the cup, got it set to 90 degrees, got it set with a gap so I could fill it with a bead. Now I have ground down the cups and installed them, both of them in place. So now that I've got those mounted, so now I just have to measure from this cup to that cup. Now I've got it loaded in the notcher here. Perfect. Oh yeah. All right, so I've got this cross member in place, shimmed on the bottom, made sure everything was level and square. It looks pretty good. We'll be able to remove it and finish welding it up. Look at these big old bolts. Got both shafts welded up and installed.
For today's sponsor, we have the Tesman TCM 300D. This is a smart digital clamp meter. Very nice. It has auto start mode for fast and intelligent measurements. So this does behave like a normal multimeter where it's got places to plug in leads. You can see when we plug it in to a normal US house socket, we get 120 volts at 60 hertz. We're gonna do some normal multimeter things. I'm gonna see which pin corresponds to which wire. Sweet. That is in auto mode, so again, it automatically detected that I was looking for continuity, beeped that I found the right wire. So this also comes with a thermocouple, so you can plug it in and it will actually show you the temperature, both in Fahrenheit and Celsius. You see when we put it on this cooking skillet, you can see it raises the temperature. It does have quite a few features. Over here, you can push this, it'll actually hold whatever value you've got. Also, you can turn on a light if you hold it down. So see, it automatically detects 12.36 volts. DC. It has TRMS with 6,000 count. For AC applications like your house, it has non-contact methods for both load and hot. So we can just grab one wire, 0.23 amps AC. For AC, you can also do things like your electrical panel. It has a flashlight and a backlit LCD display. It can test AC current, DC current, AC voltage, DC voltage, continuity, resistance, diodes, frequency, and temperature. So this is a great multimeter that will basically do just about anything you need to, and it is all for less than $50. If you're interested in something like this, I'll leave a link in the video description.
Now that we've got the cross members in, installed, welded up, we've now got to make the motor hanging subframe that's going to link the two cross members, basically going to curve over the motor. We're going to bend this to a 56-degree bend. Hope this works out well. And it's repeatable because we got to do it twice. There's 56. So that's bent. I went a little too far anticipating it to spring back. It's at 60 degrees instead of 56. Not a big issue. We'll just do the same thing for the next one, make sure that it's only 60 degrees. Okay, that worked pretty good. Now that I've notched this end, cleaned it up, fits in there really nicely. And I gotta make sure that everything stays exactly square. So I'm gonna mark this one up, I'm gonna cut it, notch it, and then I'm gonna have to take this cross member off in order to get it to fit. You know, it's gonna fit really snug, it'll keep it tight in there, and I'll be able to weld it up just in place. I gotta make these match. So far, I've done really well. Both of them are cut and notched on this end. So hopefully I've done this correctly. I've got them in place now, but looks good. Pretty happy with that. Got the car flipped a little bit so it's easier to weld. So I'm just gonna put beads on all of this that I can get to, let it cool down, then take it off, and then weld everything else that I can't get to right now. Time to take the subframe off and finish welding it. Look at those big bolts. It's awesome. Solid, man. Keep this square while I weld it. Yeah, see, that's straightened out.
John is doing a great job. I'm gonna do something that's gonna help him out a bunch. So you've seen me with motors like this on the Jeep and trying to wrestle them around just to get mounting points and things in position so I can weld. So a viewer reached out to me. He actually says he's got a mock motor that we can use, which is a lot lighter and will essentially do the same thing. He's got a website. I'll put a link in the video description if you want something like this. The goal is, though, to be able to do some of these critical motor placements without actually having to lug around that 350-pound motor. So let's open it up and see what it is.
That's pretty cool. So everything's labeled, everything's laser cut, CNC, all super accurate. First thing we got is a QR code that we can scan for an assembly instruction video. All right, so we're ready to do motor mounts for the Porsche. I've taken out the subframe. I've placed it here on the ground. I did have a bunch of other blocks underneath the cross member. Just make sure that I've got, a little bit poking out here. This is a little, not perfectly vertical. This is perfectly flat. This motor mount here is at 10 degrees to the subframe mounts. I'm gonna cut some cups from here up to the cross member, from here up to the cross member. I've got my washers, plop these in there, use the magnet and weld them up, and I'll put them on the motor mount, and then I'll start measuring and cutting this. The other thing we're trying to do is we've got the original motor mount on the side goes here. This is kind of just a stabilizing motor mount. Problem is the suspension goes right past here. This bracket that's gonna go here for our new motor mount, had Jeremy 3D print it for me. This way it gets us over even further. And so I like this way more. It gets us out of the way of the suspension that would go right here. I cut out this piece, just like the 3D print. It's actually accurate. I wanted to make sure that everything fits well, just to make sure there's no differences, so that we can cut, bend, and notch the tubing to go from the subframe to the mount. Before I do any welding on this bushing, I don't want the rubber to melt, so press out the existing one and press in a sacrificial one that we have. And then I can weld on it, we can melt it, and then I'll do the same thing. I'll press this one, or the old one out, and put the new one in. Let's get the mock motor back in place. We'll get everything spaced correctly. We'll weld all this up on this bushing, and then we'll press out this sacrificial bushing and press in the new one. Now that I've welded up as much as I can get to with this in place, now I'm going to take out the motor, the mock-up motor, and I could get to a couple more places. I'm going to put in this motor mount in its place when I do these areas so that stays correct. And then if I can't get to all of it, which I'm pretty sure I won't be able to, I'm going to pull out the whole subframe again and hit those last few areas. Are you ready for this sweet tool to get the bushing out? It's 2 sockets and a threaded rod. It's deluxe, son. Whoa. There we go. Oh, I definitely melted it. Oh, jeez. Everything's welded up. Let's find out if it still fits. right, sweet. Nice. I like it. I like it a lot. So that is the mock motor installed. It's tested on the actual motor already. Everything's welded up. We got all the mounts. We're good to go. That is the subframe and motor mounts complete. Looks really good. I'm really happy with it. Can't wait to have it powder coated and get that. It'd be nice to get it on its wheels.
All right, we did it. We got the motor mounted. That gets us that much closer to this being on the road. Thanks for tuning in. See you next time. This week we're putting, let's try this again.
No.
As you can see, let's try this again.